Okay, so we will continue with some or more examples in adding radicals. Okay, so I have here another example. I have here 5 square root of 27 added to 6 square root of 3 minus 4 square root of 48. Okay, so that is now my given. Now you need to examine and look at your given first. Now you look for radicand, that is the number under the radical sign. This one is what we call the radicand. This one the radicand. This one is also a radicand. You look for a radicand that is already prime. Now 3 is prime. That means you can get the perfect square of 3, or 3 is not a perfect number, so you do not need to simplify this part here. But 27 is not prime, so we still need to simplify 27. Okay, the radicand 27. Of course, we can simplify the number 27 by getting the prime factors of 27. Okay, we will now write all or get all the prime factors of 27. Okay, so 27 is 9 times 3. 9 times 3 is equal to 27, and 9 can still be factored out. 3 and 3, and this one here you write 3. Okay, 3 is already prime. Finally, there are 3 3's, so your prime factor is 3 to the power of 3. Now you will now write your 3 to the power of 3 here. Okay, so 5, the prime factors of 27 is 3 to the power of 3. Now of course this one is already prime, so you will just copy 6 square root of 3. Now we will now get the prime factors of 48. Okay, so to get the prime factors of 48, okay, we need to get the factors of 48. So we have 8 and 6, because 8 times 6 is equal to 48, and 8 can still be factored out. 4 and 2, this one also 3 and 2. Now 2, 3 and 2 are already prime, but then 4 can still be factored out. 2 and 2. 2 times 2 is 4. Okay, copy, copy, copy. Finally, you count how many 2's are there. 1, 2, 3, 4. So there are 4 2's times 3. Okay? Can you see? Okay, so 1, 2, 3, 4. So 2 to the power of 4, then times 3. Okay, this one now is your prime factors for 48. Okay, so I'll go back to the given. So this is minus 4 square root of the prime factors of 48. We have 2 to the power of 4 times 3. Okay, now we will now simplify. Okay, now in order to get the square root of the radical, the power of our radical should be divisible by the index, okay, or the root. Now we have our root here, which is 2. Our root here is also 2, and our root here is also 2, because this is square root. Okay, so 3 is not divisible by 2. As you see, 3 is not divisible by 2. Therefore, we have to make this one, we have to subtract 3 by 1, so that 3 minus 1 is equal to 2, and 2 now is divisible by 2. So we will rewrite that one with 3 squared times 3 to the power of 1, because 3 plus 1 is equal to 3. Now this one you just copy, okay, minus 4. Okay, now you do not need to rewrite this because 4 is already divisible by 2. So you just copy 2 to the power of 4 times 3. And then, we're almost done here. Okay, then you will now get the square root of 3 squared. Okay, so 2 divided by 2 here is 1. So you will multiply your square root of 3 squared, which is 3. Because 2 divided by 2 is 1. So there's power 1 there. And then 3 is already prime. So that is left under the radical sign here. Okay? So plus 6 square root of 3 minus 4. It will be multiplied to the square root of 2 to the power of 4. No, you just divide 4 by 2. 4 divided by 2 is 2. So your square root of 2 to the power of 4 is 2 squared. Okay? So 3 is prime. You cannot get the square root of 3, so it is left under the radical sign. So finally, we are going to multiply the things that are outside the radical sign, or we call it one of the coefficients. Okay, so we have 5 times 3. 5 times 3 is equal to 15. You copy square root of 3 plus 6 square root of 3 minus, okay, for this one, 2 squared is 4. Multiply it to 4, that is 16 square root of 3. Okay, so finally, they now have same radicals. So they are now like radicals. So because they are like radicals, we can now combine them, okay, by adding or subtracting the coefficients. So the coefficient here is 15, here is 6, and here is negative 16. So we will add 15 plus 6 is 21, minus 16, we'll have 5. Finally, you have 5, and then you copy the radical square root of 3. So this is now our final answer.